circuit which causes current to flow, similar to a pump that pushes water through a pipe.
A potential difference exists at only two places in a circuit, at the source, known as the voltage rise, and at the load, known as the voltage drop. The symbol E is used to identify a voltage rise. The symbol V is used to denote a voltage drop. If there are two or more loads in a circuit, they can be represented as resistances on a schematic diagram, and the voltage drops across them are identified as V1, V2, and V3. The voltage source would be labeled ET. A voltmeter is used to read both the voltage rise and the voltage drops in the circuit. If the loads are connected in the circuit so that the same current flows through every part, it is a series circuit. The loads are known as series loads. As the current flows through a 10 ohm resistive load, a voltage drop is produced across the resistor. The voltage drop is equal to the current flowing through the resistor times the value of the resistance. In this case, it is 500 milliamps or half an amp times 10 ohms or 5 volts. If another 10 ohm resistor is added to the circuit, less current will flow in the circuit. In this example, only 250 milliamps or a quarter of an amp will flow through the circuit. The voltage drop across each resistor will decrease to approximately 2.5 volts.
This principle also applies to alternating current circuits, when a voltage drop occurs when current flows through a lamp or lamps.
With two 100-watt lamps replacing the 10 ohm resistors and 120 volts AC being applied, the approximate half-amp current flowing in the circuit produces a 60-volt drop across each lamp. Adding a third 100-watt lamp decreases the total current further, resulting in a smaller voltage drop across each individual lamp. In this example, approximately 40 volts are measured across each lamp, and the current is reduced to about 4/10 of an amp. Notice that if the voltage across the three lamps are added, the total voltage is equal to the voltage applied to the circuit within the accuracy of the meters. This is known as Kirchhoff's voltage law. In this case, the applied voltage is divided equally across the three lamps, since they are all 100-watt lamps.
This may not always be the case though. The proportion of the applied voltage that's dropped across each load depends on the load's resistance value.
By replacing one of the 100-watt lamps with a 75-watt bulb, the voltage drops will not be equal, but they will still add up to the applied voltage, which is in this case 120 volts. The 100-watt lamps read approximately 32 volts, while the 75-watt lamp reads 56 volts. Notice that the brightness of the lamps are affected as well.